to my computer. You're all set?
It'll be a very informal discussion of how the Geo self-service framework works to replicate and verify everything that it does. I kind of like. It would be nice to have a whiteboard. But we'll just talk.
Sure.
So
we could use Paint or something like that if you got it.
Yeah,
what is the equivalent of Paint on the Mac?
That's okay. It would look so childish. Okay, so
PowerPoint,
Google
Slides, would they help? Maybe describing things. If not, don't worry, we can get.
Oh, well, first, like, since we're gonna first talk about the overview, we can look at the this little diagram here. So first, Geo, the idea is you have your GitLab deployment and you have maybe another location with many developers at that location who are cloning, and it's taking a very long time because it's on the other side of the earth. So you create another GitLab instance, just like you're installing, another GitLab for them. But you use Geo to make it follow the primary site.
Gotcha.
So, I guess we may as well go through all of the pieces overview. What's going underneath here is the Postgres database, which is the main database of all the data in GitLab, is being replicated with just standard Postgres streaming replication to the secondary site. And then it's kind of Geo's job to replicate everything else, which is like Git repos and logs of various types. That seems very simple on its face, but when you get into how do you make sure that everything is replicated, and how do you make sure that there was no corruption on the way over, for example, or how do you make sure the secondary site, like say somebody, a sysadmin accidentally deleted a whole directory of blogs or repos, how do you know about that? Because it really needs to be there for people to use it and for disaster recovery. Geo was initially written to replicate Git repositories for projects, and it worked. And we also added support for uploads, which are, for example, if you make a comment in an issue or a merge request and you attach an image, that's an upload. If you create an avatar, upload an avatar branch, that's an upload. Things like that. A lot of things fall into that table. And then we also replicated LFS objects and job artifacts. So that was all working okay, except that every time we added a new type like job artifacts, it was like a massive effort. It would take a single developer, 6 months to accomplish. And meanwhile, we also added on for Git repos, for project and wiki Git repos, verification. And what that would do is it would take all of the refs in the Git repo and checksum that on the primary and on the secondary, and it would compare the checksums. And if it didn't match, then we would know that we don't have everything on the secondary. Now, that's kind of not, yeah.
Sorry, what do you mean by refs in this case?
So if we go into like what the structure of a Git repository is, the refs are pointers to in the end, it's kind of like pointers to all of the data.
Okay.
In the Git repo. That's a huge simplification, but that's basically it. And I'm not a Git expert, so other people will be able to explain that better.
As an example, there was a commit. There would be a ref for that commit, for example. Would that be accurate, or is there a ref for a comment, etc., or have I misunderstood the concept?
So now you're testing my Git knowledge. So I'm just trying to remember what it's like, and I think it's more like, say you have a Git repo with a whole bunch of commits, but only one branch, master,
yep,
or main, say main. And so what you're going to have in the structure of the Git repo is you're going to have main, refs, heads, main, something like that. And you're going to have head. So you're going to have two main refs, and they're both going to be pointing to the last commit.
Okay. Right.
In the chain of commits. I don't remember what happens after that.
we can look into that offline, so no problem.
Yeah,
let's continue.
So yeah, so that's a good but that's a good way, enough to say checksum the refs is not enough to know that nothing is corrupted. But it's a pretty good way to say that if it doesn't match, then you definitely don't have everything.
Gotcha.
Yeah. So anyways, that verification piece was added. And as part of that, just managing like the process of like, okay, checksum all of the Git repos on the primary, checksum all the Git repos on the secondary, do the checking. If it doesn't match, resync. There's a whole bunch of logic and a whole bunch of data that needs to be stored in the Postgres databases to make that happen. Which reminds me, we need to mention the Geo Tracking Database. It's just a separate Postgres database in the secondary specifically, which has tables like the project registry. So for every project, it's going to have a corresponding row in the project registry table in the secondary. And it's going to have data like, is this synced or did it fail sync? When was sync attempted? If it failed, when should we retry a sync? When was verification attempted? Well, did verification fail? If so, when should we try verification? All that kind of stuff.
Okay.
And there's a table for each for projects, for uploads, for LFS objects, for artifacts in the Geo Tracking Database. Okay, and for Git repos, the basic way that something is replicated to the secondary is the secondary actually does something similar to what a user would do. It does a git fetch against the primary site for that particular Git repo.
Okay.
And it authenticates with JWT authentication, which I'm not a security expert, but it's that piece was needed because it's like it's not a user on the secondary doing a git fetch. I don't know what other reasons there were for choosing that method of authentication, but that's what it does.
Okay.
For things that are not Git repos, things that are blogs, which are basically just files in the file system, for example, or in object storage. Uploads, job artifacts, LFS objects, those are all basically blogs. The primary has a geo-specific like API endpoint, which the secondary can call to say like, hey, give me this upload, or give me this job artifact, or give me this LFS object.
Okay.
And it's just an HTTP, file transfer.
Okay. Gotcha.
So that's kind of the overview.
So if I may, the secondary, it fetches all of these individually, so it'll get a list of objects, blobs, for example, that the primary has into its tracking database. Then it knows what it synced, what it hasn't, and then it will fire off jobs to fetch the missing. Let's take blobs as an example. To go fetch those, and there will be a separate request for each item from the secondary to go fetch. It wouldn't be like, I want these items as a collection. It would be individually firing off requests.
Yeah.
Gotcha.
Yeah.
Okay. And would it also fetch the checksum for verification? Is there an API on the primary for that? How does the checksum come
The
up?
nice thing with doing the Postgres streaming replication as kind of like an underlying layer is that the primary, we can send data to the secondary just through that, so we don't have to make calls for absolutely everything. So yeah, the primary will just check some things,
have it stored in the
database. Yep, and the secondary will see that.
Gotcha.
The secondary, so that kind of gets into backfilling versus like events. But yeah, do you have any other questions?
I think you've touched on it, so I'll wait for that topic to be discussed before I ask any questions. So yeah, let's get into it.
So So let's just go with, we're going to just talk about self-service framework, how that works.
Mhm.
Because we're just going to be talking about the logic, just like the logic of like, how do we do this and do that? And it will be, we're migrating projects currently to SSF, so we're pretty far along, and we don't need to remember all that old stuff.
Mhm. Yeah,
Um,
let's kind of focus on the SSF flow
yeah,
rather than the legacy.
yeah. So there's a lot of moving pieces. So we'll start with kind of how the development of SSF like started and how it grew. So the beginnings of it was, we know that we want the secondary to do things responsively. So like if something changes on the primary, we want it to be reflected on the secondary as soon as possible. And that means that we really shouldn't be doing it with some kind of like just background process churning through every single thing, looking for what needs to be synced. That's too slow. So we need to implement some kind of eventing system. There's like so many ways to do it. One of the choices that we made was to, one, not introduce new infrastructure, like RabbitMQ, things like that were certainly brought up because it's purpose built for that kind of thing. We just built it on top of Postgres. We already had some kind of architecture doing that for the legacy logic. So we kind of just built on top of that for SSL.
Was that
Yeah,
decision just to keep the architecture simple, not to complicate the architecture by introducing more components into it?
yeah, there should be a very high bar for introducing new architecture, new infrastructure, new dependencies. Like GitLab Geo, one of the values is like boring solutions, and I think it makes sense for our purposes, and it certainly has been working so far.
Okay.
So
cool.
So from the outset of self-service framework, we already knew that we were doing a lot of the same thing over and over for uploads, artifacts, and LFS objects. So we knew we wanted to make everything that could be reused reusable. So we started building it where it was like there's like a I should probably jump to so there is a document for kind of like the overview of the self-service framework. Now, it hasn't been updated a lot in recent months, but it does still basically work the same at its heart.
Okay.
Yeah. So maybe before we start, it is worth like just briefly talking about like the names of things because many of them are overloaded.
Sure.
I'm going to skip over model because that was kind of confusing. So I'll say like a resource. Like a resource is the thing that you want to replicate, basically. A data type is okay. So we've kind of done a terrible job of sticking to this definition because we talk about different data types all the time. And I say like, okay, uploads is another data type, LFS objects is another data type. But here in this document, we're saying a Git repository is a data type, a blob is a data type, and like Postgres database is a data type.
So we could probably call these the fundamental data types, and
Yeah.
others are okay.
Yeah, yeah. Um, okay, a replicable, that's the thing you want to sync. It's a resource that Geo wants to sync. So
Gotcha.
Just
a quick question.
Yep.
Is there a good example of a database in this scenario where we would want to replicate a database? Or is this just future proofing?
Well, so the Postgres database, you have to
It's
set
a
up
Postgres database. Gotcha.
Postgres streaming replication.
But does that happen through the SSF framework, or does the SSF framework use that for its own?
It doesn't. It doesn't happen through the SSF framework. Yeah, we just say we got to set up Postgres replication somehow.
Gotcha. So there isn't a data type that is a database today, but we could have something like that in the future.
Yeah. Well, I don't think so. I think it'll be because like for the kind of database, it'll always be like different. If we were going to make the SSF handle some kind of thing like that, then it would have to be like for some reason you've got like 100 container registries or something in GitLab. I don't know why it would be like that, but you know, otherwise I don't think we're gonna I don't know. Does that make sense? I'm not really sure.
I don't quite follow, but we can come back to that. I was just curious. I totally understand Git repositories, get the blobs, the database. Obviously, there is a Postgres database, but to me, it feels like the Postgres database forms part of the SSF framework rather than the SSF framework managing the Postgres database. So we can come back to it. Don't worry.
Accurate. That's definitely accurate. And you know, I don't like, so the SSF doesn't handle container registry, but container registry is basically a database.
Okay. As we're looking to pick that up soon, right? So that would make sense. Okay.
Yeah. Okay. But anyway, so moving on, a replicator. That's kind of more like if you're in the code, like you're looking at the Ruby code, like you need to know like the replicator is the object that knows how to replicate something.
Mm-hmm. Gotcha.
You'll call a method on the replicator to fire events, which is like from the primary. And then in the secondary, you'll call a method on the replicator to consume those events. Does that make sense?
Interesting. So the primary triggers the replication. Is that the way to look at it?
Yeah. So yeah, because of this whole like eventing idea,
Yeah.
in order to keep the secondary responsive. Yeah, the primary needs to somewhere, somehow, when something's changed or created, fire an event.
Puts it into the database, which gets sent across to the secondary. So it's a primary creating the entry in the database. That's the producing part, and then getting replicated. Then the consumer would be the secondary when it actually sees the replicated data at that point. Gotcha. Just wanted to make sure I understood the model. Thank you.
Yeah. Oh, and initially we tried to write this so that we could swap out the underlying eventing system if needed. I think it's turned out to be that we won't need it, but yeah.
Okay.
It's something to know. So the old code that we used to carry these events from one side to the other is not described in here, but remind me to talk about that later. And then the last thing here, it mentions Geo DSL. Okay, yeah, I don't know if we're going to talk about that. So now we're going to start looking at the Ruby, code, the DSL that we have going on in the code base. Yeah, so to replicate something, you write a replicator for it. So that's going to be like package file replicator class. And ideally, you don't need to write a whole bunch of specifics like, code yourself, because as we know, downloading a package as an HTTP file transfer is the same process as downloading an upload and a job artifact and a manifest object. So most of that stuff should be handled by, the superclass GitLab Geo Replicator and the strategy that you include. So in this case, log replicator instead of repository replicator.
Gotcha.
And you're going to have to specify some, the actual specifics, like, okay, if you call dot file on this thing, then that's going to give you that's going to give the strategy this thing that it needs, carrier wave uploader.
Okay.
Or the model here, packages colon package file is the active record model that represents the packages underscore package underscore files table. And so, yeah, all the replication logic is hidden. You only need to say like the actual specifics.
So you're inheriting from the superclass, as you say. All of that is just under the hood.
Yeah. And here in that active record model, the package file model, we tell you got to include this thing because that's going to provide some the ability for like the replicator to call certain methods on this model. And also say that replicator, package file replicator, that replicates this thing.
I see.
So for example, if you have and we're talking about Rails code now, I mean, because this is active record, you can do package file dot find that ID. You can call dot replicator on it, and it gives you an instance of package file replicator.
Okay.
And package file replicator. Oh, sorry, go ahead.
Oh no, is it, what does the ID represent there?
Oh,
I can
it's
keep
the
my
ID in the table of that row, a particular row.
okay, gotcha.
So like
So it's
in your browser here, for example, like issues number 11, that's the IID.
so that item okay, it uniquely identifies the item in there. Okay.
Yeah.
Okay.
Yeah. And you can do the reverse here. If you have a replicator, you can call model record method, and that'll give you the package file instance.
Okay.
And here it says you can use the replicator to generate events. So again, if we're in the primary, if you call publish created event on a replicator, that is like if you got it by doing this, like you have the package file model instance, and then you do dot replicator, and then you call publish created event, that will create an event in the database that says, oh, this package file number 4 was created, so that the secondary can act on that event.
Right. So it writes it to the database, which then gets carried over to the secondary. Secondary sees that, and then comes in, fetches the file from the primary.
Gotcha. Okay. And down here it mentions we have blob replicator and we have repository replicator.
Yep. And let's say the primary initially so somebody added a whole bunch of files, right? Blobs. I'm going to stay generic on this. 100 blobs. Would the producer generate 100 events immediately, or is there a throttling algorithm there to not overwhelm, for the secondary not to overwhelm the primary? So is there a or does the secondary manage that on their own? What mechanism stops that from happening?
So yeah, so it creates them all immediately. Now it depends on, like, if you have let me think. Example. So like if you push to your Git repo, in the back end, there are some things that are done synchronously with your push. Everything that's done synchronously with your push slows it down. So for at least that reason, a whole variety of things are done asynchronously. So when you do a push, then a job is queued somewhere. And I believe that's true in the case of Git pushes and Geo, like repository created events being created. So it's done asynchronously. So, if you don't have enough sidekick workers or the amount of pushes that are happening, maybe it just happens to be that there are a ton of pushes at this moment, but that's not like the average. Then you'll get a growing of the sidekick queue of all of that stuff happening in the background. Does that make sense?
Yep, and the queue is serviced at something's dispatching the work, right? So it'll pick, So I guess the sidekick queue is on the secondary side, right? And
Oh,
it's
no, no. So
dispatching.
we're talking about only the primary.
Okay,
For creating those events on the primary side, the producer side,
right.
I believe that that's done asynchronously. So you could end
So
up with a pile of sidekick jobs that are not yet executed for a little while.
gotcha. So just to make sure I understand this correctly. So when you commit a change or create let's say you create a project that initiates a sidekick job that's responsible for writing to the database, which then gets replicated to the secondary. That's the flow of events. So nothing writes directly. The task of writing to the database gets enqueued on the onto a sidekick job, and okay, understood.
I believe so. Yeah.
Cool.
Yeah, so see, we've got this post receive worker, which is post receive is like the big thing that happens on a push.
Mhm.
Post receive is like one of the Git hooks. So this is a worker. So um, yeah, this is a sidekick worker or a sidekick job
Mhm.
definition, basically. And in here we have a hook into the free and open source code. After project changes, if this is a geo primary, then call this repository updated service. And in there, we create that record.
Okay. Okay. So that all happens inside the primary. Understood.
So to your question, there's still an opportunity for the secondary to have more to do than it can do within like a second.
Mhm.
Um, so like, let's say the primary sidekick is, fast enough. So 100 repository created events get created in the span of a second. Postgres streaming replication has to bring those rows over to the secondary.
Mhm.
And then I guess here's what I was when I asked you to remind me about what happens. Here's where we get into a detail of the event system. On the secondary, there's a process called Geo log cursor,
Mhm.
and all this process is doing is watching the event tables. There's actually one event table and many specific event tables that uh,
Feed into it.
are tracked by that one event log table. Yeah.
Okay.
But so it's watching the event log table actually, and it's
Mhm.
just looking for new records that it hasn't seen before.
Okay.
So when one appears because of Postgres replication, then it uh, it calls the specific event code, like event processing code for that specific type of event, like
Mhm.
repository created event. So it's like specific code is called for each of those types of events. And in the case of repository created event, what happens is it creates the project registry row if it doesn't exist. And it marks it as pending, needing sync. And then it enqueues a replication job.
Mhm. Okay. Right.
Oh, So it's a little bit different from SSF, although in the end it's the same. The SSF has one event type because we're trying to get away from like every time you create a new
Data.
data type or event type,
Mhm.
you need to like create a new table and it references the geo event log. That's like a whole bunch of overhead that's not helpful.
Gotcha.
So in the SSF, there's only one event type, and it's just geo event. It had to be generic,
Mhm.
and so when a new event comes in, like created event or updated event or deleted event, then it creates a geo event job
Mhm.
where that job has all of those arguments. It says like, oh, this thing was created, or this thing was updated, or this thing was deleted.
Okay.
And so in the end, you get a sidekick job that will do a replication or deletion or whatever.
Okay. I understand. If it's a deletion, it would need to do that locally. But if it was a addition or a replication, then it would need to establish a call to the primary and fetch the data.
Mhm. Mhm.
Okay.
Yeah.
I guess if it's an addition or a deletion, it would need to go. If in the case of blobs, it would need to go bring that. Would the blob have the same reference if it was updated? It would just have the same reference. It indicate that it's been updated. Yes.
So
Or is there
one
a
weird,
new record that's created every time? Something.
yeah. So almost every blob is immutable,
Mhm.
which is super convenient for Geo. Not just convenient, it's like the right way to do it. um, and so there's no updating of
Okay.
them. But we actually have some blobs that are mutable, and it's terrible.
Okay.
And I think it's avatars. Like if you update your user avatar, there's some bug around that currently.
Okay.
That's because they're just updated in place.
Right. Right. Okay. Yeah. Right. Okay. But in general, it's immutable, so there will just be add and delete as a we'll just assume that. Okay, cool. And so the sidekick is responsible. Ultimately, it is the worker that's responsible for talking to the primary and managing the download of the. Gotcha. Okay.
Yeah, all the requests for repositories and files against the primary are going to be coming from secondary sites sidekick nodes.
Hmm.
And one of the one of the things is like if you uh, um, like the web nodes, right? Like like the UI of GitLab, like it has short timeouts because if you don't do that, then you're susceptible to um, DDoS attacks and all kinds of problems,
Hmm.
not malicious ones. But Sidekick can, it's not ideal if you can avoid it, but a Sidekick job can run for 12 hours or
Okay.
whatever. And in some cases, that really is needed for something like if you've got an LFS object that's like, 10 gigabytes and you've got like a 10 megabit connection on the other side of the world. That's the only way it's going to happen. It's going to take a long time.
Yeah. Yeah. So that's okay. Sidekick can keep that channel open, or this is a problem that we face at the moment.
I mean, it is a problem if that is actually happening. If you get any kind of like you end up being very susceptible to like corruption and whatever, but
So
we'll
uh,
retry.
do we need to flag this when this type of thing happens? I guess would be a question to the customer.
Yeah, so
Um,
there's been discussions recently around like establishing expectations for Geo in different scenarios. And this is one area that, yeah, we haven't really done a lot yet.
okay.
In the case where you've got like a terabyte of data in your primary and your secondary is on the other side of the world with a 10 megabit connection,
Mhm.
you're just not gonna have a great experience. It may never catch up. It
Mhm.
it may not be technically possible for it to catch up.
Sure, sure. Gotcha. Okay. But it's so I've heard workhorse being mentioned. So and I'm kind of going off reservation, and apologies for
Sure.
that, but you got Sidekick who manages, you know, writes to the database, also manages calls out to the primary from the secondary, and manages the downloads. What is workhorse responsible for?
So if you imagine like the web, UI of GitLab, those are served by those requests are served by Rails. But in between, you have a component written in Go
Mhm.
called Workhorse. And the reason is there are a number of very specific um, types of requests that can be handled uh, much more efficiently, not by Rails.
Mhm. Right.
um, so, like, for example, if you are doing a Git pull of a huge repo,
Mhm.
um, we really don't want that request to be served directly by Rails.
Okay.
Um, and so what happens is Workhorse um, is able to talk to Gitaly and bypass Rails. I mean, Workhorse also is able to talk directly to the Rails app to say like,
Mhm.
is this user authenticated for this thing? But when it gets that authentication, then it can ask Gitaly directly for,
Okay.
for
Right.
that.
Gotcha.
And
Okay.
you bypass Rails completely. So
For the
because
moment, Geo
Rails,
doesn't use Workhorse. It's just Sidekick.
uh, yeah. So okay. So on the primary side, right? Um, Workhorse is getting used for serving the Git repos,
Mhm.
right, to the secondary during the
Yeah,
sync. And also, I mentioned that
I got you.
for jobs, yeah, the endpoint,
But that's
uh,
done through an API, though, right? So it's behind when the request to fetch the repository comes in. The primary kicks off the Workhorse job, and that starts to serve up through
Workhorse.
that.
It's not really like yeah, it's not really like a job thing. It's more like Workhorse is an HTTP server. Uh,
Okay.
and yeah, and like by default, most requests are just passed through to Rails. But
Mhm.
when it makes sense for us, when it's more efficient to handle it in that Go HTTP server, then
Okay.
we do it there.
So you've got the single. Sorry, Mike, I'm going into details here, but you've got a single API. Something intercepts the API call and decides whether the job, whether or the endpoint is pinned to a sidekick or a workhorse kind of.
Not Sidekick. So the Rails app is running in like Puma, another
Yes. Yep.
HTTP
I've
server.
Mhm.
So many layers to this. Yeah.
So okay, cool. So when you ask for the repo, basically it just hits the workhorse server and it just gets served from there. So the API hangs off workhorse. Would that be fair to say or not? The API
It's
different endpoints hang off different things. Puma, some
so
API endpoints could hang off Puma one, some could hang off workhorse.
yeah, um so let's forget requests.
Mhm.
Okay. Can you say your question again?
So so for different API endpoints, do they have different? Are they backed by different services? Like um, let's say a Git request that goes to Workhorse, but let's say a blob or something like that, right? Does that get serviced by Sidekick in the end when they come in? So let's say you got the same API, but they've got different endpoints within the API. So I guess you're hitting a request to replicate uh, uh, Git repositories, or you get another request for blobs. Are they all hitting the Workhorse
Yeah,
HTTP server? Everything hits the Workhorse.
all HTTP requests go through Workhorse
Oh,
first.
okay.
Or what? Okay, so like if you were imagining your typical GET deployment,
Mhm.
Nginx first, and then from there it hits Workhorse,
Workhorse, right?
and then Workhorse will split off a number of things. Like it'll it'll handle Git requests itself.
Mhm.
Um, it'll if you are using uh, object storage for uploads and things like that,
Mhm.
Workhorse will directly handle contacting object storage for
Okay.
the authorized URL. Let's send that back.
Mhm.
Uh, um, wait, there's a couple ways that it does object storage, but anyways, yeah. So it handles those, and
Okay.
then if it's a blob download request, um, we wrote the API endpoints in Rails.
Mhm.
So if it's not stored in object storage, actually, I'm wondering now, maybe it is limited by a timeout in Puma and Rails, like lockdown though. Does that?
We can come back to that.
I kind of
Look into it.
forgot about that.
That's cool. But that's good insight. I've kind of learned a lot with regard to Sidekick and Workhorse here. So thanks for that. But let's continue with SSF. Sorry for the digressions.
No, I mean, that is part of SSF, the endpoints for downloading blobs from the primary. Um, it's the same one endpoint for all the different kinds of blobs, and it's kind of all hidden behind the Replicator strategy.
I see.
Um, but yeah, I don't know, not sure where we were. Oh, so we had kind of covered a lot about like when an event is created, and then how to like what happens, if
Mhm.
sync happens, right?
Yep.
So outside of the event system, there's a couple things that need to be handled. One is backfilling. If you have a large GitLab deployment and you've got a ton of data, a ton of users already using it, you're not using Geo, and then you add a Geo secondary site.
Yep.
Then everything that you have needs to be replicated to the secondary, regardless of whether someone is actively updating those things or whatever. So that's one thing that needs to happen. Another thing that we learned with Geo is that we can't depend on the eventing system 100%. And that's for like more than one reason. One is like if somebody does a push on the primary and there's like some kind of transient infrastructure problem, or there's a bug in the current release where the post receive worker, for example, raises under some specific condition before the Geo repository created event is created, for example. Gotcha. Whatever, there could be many reasons, or like a sidekick job is just lost because that can happen. And or maybe on the secondary there's a bug in the geocode and those jobs just die for some reason. So events can't be relied upon 100% because if you do, then you'll eventually see, or you'll have customers seeing like, hey, this thing was supposed to be synced, but it's not synced. Like, and now what? So we have to kind of assume that events are not reliable.
Okay. Okay, cool. I think I want to. I'll let you continue with the backfill strategy because I want to. I've got a couple of questions coming up already.
Okay, sure. So the way that it works currently, it's nothing fancy. There's one of the main components is like this job that runs in the background, and it basically runs all the time. And it looks at it looks at every single record of the source table, and it looks at every single record in the registry table, the corresponding registry table, and it says like, is the registry table missing the registry that should exist? If so, create it. Does the registry have records that don't exist in the source table? If so, that should have been deleted already, but we'll delete it. So that's happening. And then there's another job that says like, is checking only the registry table, because you don't want to do big cross database queries.
I see.
You don't want to do cross database queries in general, like
they're expensive.
Yeah, they're expensive, they're slow, there's a number of things that can go wrong, but anyways, so there's another job that is constantly just looping over the registry tables. Well, not looping over the registry tables, it's doing queries on them, because now we can do full queries, like give me everything that is pending sync that's never been synced. Okay, enqueue sync jobs. Give me everything that has failed that is ready to be resynced because it's past the retry at time. Okay, enqueue some jobs for those. But we also need to manage like if this thing were allowed to do all of that as much as it wanted to, you could easily end up in a case where those sync job queues grow infinitely.
Mhm.
So that's a problem. Also, even if like the deployment has tons of sidekick workers, you don't necessarily want to just saturate all of them with geo sync jobs
Yeah,
at the same time.
makes
That's
sense.
bad for the secondary. That could also be bad for the primary.
Right.
Um, so we have maximum concurrency settings for these sync jobs.
For Geo,
Um,
for Geo.
yeah, for Geo. And there's just settings that you can go and kind of simple at the moment. And it's per secondary.
Mhm.
So if I go to the edit secondary site, here's file synchronization, concurrency limit, container repositories, concurrency limit, repository, and then verification,
Mhm.
which that's what we're talking about. Yep. Um, one of the problems that we have currently is that these are the defaults that are set when you create a new secondary.
Mhm.
This is like totally inappropriate for everything except for the specific size of deployment that this is good for, right?
Okay. Yeah.
So like it's inappropriate for the GDK. In fact, like I always like go in and put like, something like this.
Oh, I see.
For the GDKs. So yeah, that's a problem that we have. But you can tweak those,
Mhm.
and that's so easily worked around if you have a problem with like, oh, I got too many some jobs.
But we don't provide customers with guidance on what those should be at the moment, right? Would that be fair?
Not really. And it's extremely difficult to provide that kind of guidance. And so yeah, that's why I just propose this epic.
Mhm. I
Um,
remember you sharing this
as
earlier this week.
we can, yeah, we can do tests on a specific setup that we can define, and we can say like it's on GCP, and we can, I just added this, take a measurement of bandwidth between sites. So we can tell people like, okay, if you've got a thing in GCP US East and a thing in GCP Europe West of these sizes, reference architectures of GitLab, and your bandwidth, is approximately like this. This is the behavior that you can kind of generally expect from Geo. Now it depends on like so many things, like how many users are currently using your primary and secondary, what are they doing? But
Gosh, yeah.
at least if we do this kind of if we define this kind of a reference architecture,
Mhm.
maybe
It's a good
10
place to
figure.
start, right?
It's a good place to start, and we can kind of map out a space
Mhm.
what to expect.
Cool.
Yeah, currently there's no guidance. There's like no way to give.
But the default values are quite high, I guess, from
There, I guess I should say, so originally Geo mostly was developed for like, we've got a single node for each site. And, maybe it was like not a small node, but I think those defaults probably came out of that. So if you set up omnibus GitLab on both sides on like a healthy size node, then the defaults of 25, 10, 10, 100, like you'll be okay. Probably.
Okay. Cool.
Yeah.
All right. So we discussed the concurrency setting for this.
Yeah. So yeah, that's most of sync. I mean, there's so many details we can dive into. You mentioned you had some questions before I went into the backfilling.
Yeah. So the backfilling. Let's say you're syncing a large number of jobs. Let's say you just started. It's a huge repository or large number of projects, right? What I think you've answered that question. The concurrency throttles you from overwhelming the primary or overwhelming the secondary, overwhelming itself. So I think you've already answered that question there. In terms of um, information with regard to the sync activity, what type of information do we have with respect to, let's say, a repository sync? What type of information do we have in relation to where the primary and secondary are with respect to each other? Um, you know, how many outstanding requests, etc. What's the deviation between the two? How many are in flight? Things like that. Do we have typically that type of info? This does relate back to the question here, and you mentioned there was. Is it this information that we have? Is this a good?
So yeah, mostly. So this is the registry. This is the snippet repository registry table.
Mhm.
These are its fields. So we can talk about some of these. So like state, that's the big one where it can have 3 states at the moment. I think 4 states. 0 is pending, meaning like it just needs to be synced. It didn't necessarily fail before.
Yep.
And then 1 is started. So it's actually turns out to be very important to track started, especially if you have mutable types like repositories,
Mhm.
um, because of race conditions.
Okay.
And 1, 0, 1, 2, 2 is success. So it was successfully synced. or 3 is failed.
Mhm.
And this is the main field to look at if you're wondering about.
So is there somewhere where all of the different values are defined for these ones, for these
Yeah,
fields?
yeah.
Maybe you shared it
In
and I missed it.
code, not in the not
That's
in
fine. If there's a single file, then I'm happy to kind of uh, eyeball it just to get an idea of different 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 values that these could have.
yeah. So here.
Awesome.
And this replicable registry is included in all of the registry models. Sample state machine, yeah. So state machines provided by state machines jam to give us this DSL domain language around managing states. So like, for example, if you in the code remove a registry to started,
Mhm.
then we set last synced at field to time.current.
I see.
So that's setting like when did it start.
Mhm.
And then then if you move it to pending, then we zero out the failure retry at and retry count.
Okay.
If you move it to failed, then we add one to retry count and we set the retry at based on what is the retry count. And oh, that's an interesting thing to note. We use progressive back off in general for anything like
Right.
failed retry handling.
Mhm.
And that's where this comes sort of in, is most retry time is
Mhm.
based on retry count.
Mhm. Okay.
If you if you move something to synced, then we zero out retry count. We clear any sync failure message, and we clear retry at. I don't know why it's like this to zero.
Okay. And you've got a last sync failure free float. I'm assuming that's a free float text field. There.
Yeah, that's right.
Okay. Is there a limit to that field? For
There
example.
is, and it was kind of arbitrary, which I regret setting it to like 255.
Okay.
But it's actually not consistent across tables because of a problem where we started saying that you have to use the text type field instead of varchar, and text requires a limit to be set as a constraint separately, but we are using schema.rb, which did not track those things. There's a whole
Okay. I'll think that. Okay.
mess. But yeah, so they're totally inconsistently set. But what I want to get to is a place where we have a text field with like maybe 4,000 characters allowed,
Mhm.
and we drop in the whole backtrace because like it's not enough to just give the one little last error message.
That was going to be my question. Is it possible to isolate the the failure log messages for this particular event? Sounds like there is, which is great news.
Yeah, we just need to
Okay,
do
cool.
that.
All right.
Number of places. Let me see, last sync failures set. Maybe not that many. So you'll see it below.
So one other question. When you look at the logs, I'm assuming this information comes out of the Rail. Is it Rails logs that this information is coming?
Yeah.
Yeah.
Um,
Is it if you look at the console, you wouldn't see this output, right? The Rails console.
which outfit? Sorry.
So when syncing fails, for example, and the backtrace, where would you find that information? Before we surface it anywhere else, where would I normally go to look for this information if I was a sysadmin?
Yeah, the sidekick logs. So if you go onto this sidekick node, it's a
Mhm.
separate name, and you tail sidekick logs, then I think you should see backtraces, or yeah.
And would it be possible to? I'm assuming Sidekick does more than Geo work, right? Would it be possible to identify the Geo logs from there? Are there any kind of prefixes or anything that you could look for to isolate it, to filter on the Geo specific logs?
Oh, you know what? I'm sorry. Okay, so if I might have spoken about. I think that's part of the problem with the way things are at the moment.
Ah.
If you transition something to fail, reset last sync failure of the error message. We truncate it to 255, but the problem. Oh, why am I searching for fails? Okay. Oh, right. Okay, good. Yeah, so that's part of the problem. I think we're swallowing the backtraces.
Okay, I see.
Because this takes the message. Oh, maybe we're not. Uh, okay. Maybe we're not. So, I mean, I guess, in some cases we are like, not, but
But if we wanted to troubleshoot what was going on, it would be possible to fetch the logs from a Sidekick node. Not in here, but is it still possible to find the log somewhere, or are they just not being written out?
yeah, so normally if the sidekick job gets like an exception that's not um, raised or not, I'm sorry, not swallowed. I believe it outputs the backtrace. I'm actually not 100% sure. Um, yeah, we need to double check on that. Because it's
Yes.
because yeah, we know like when there's a problem with syncing or something, we really need to see the backtraces. So um, it helps if that can be found in multiple places even.
Hmm.
Like if we store that and still raise so that sidekick jobs are raising exceptions with backtraces. Then if Sentry tracks it, that would be good. That is something that we need to double check on what is exactly.
Okay.
Not
Cool.
sure.
Yeah. Let's pick that up on after the call.
It must be okay. It must be swallowing it somewhere that I'm just like missing at the moment because
Yeah.
like in order for failed to happen, right? Like it's got to be executed. So the error is not being raised and it's not being raised here. So yeah, I think it's being swallowed at the moment.
Okay. Cool. Maybe that's something we could look at improving, like you say. Awesome.
Oh, so we were talking about the states syncing. And we basically covered all that before transitions. There's an active transition here for when something gets not synced, but successfully synced. Uh, active synced, which okay. So, oh, I thought, oh no, yeah. Okay, so I'm working on this code at the moment.
Okay.
And this is master, and it's not my code, so I changed that. So yeah, after synced, what needs to happen is we need to mark the base verification pending, so that, regardless of whatever happened with verification before, we know that it just finished syncing, so it's probably changed. So we'll just say like this needs to be verified.
I see. Okay.
Yeah. And it doesn't have to, like, we don't enqueue a job here or anything for verification, because it really doesn't have to occur that quickly. There's already a verification job that's like looking for things that are pending, just like the backfill one for syncing. It's like, is there anything that is verification pending? Is there
Yeah.
anything that failed verification that's ready for retry?
Mhm.
So after sync, that happens. And I'm gonna gloss over this other stuff for now.
Sure. Sure. That's fine. Yeah. Okay.
Yeah, that's basically same thing. I think.
So it basically gets the checksum, which is synced across from the primary. The verification job runs a. Is it checksums that we use for verifying? Do we
Yeah.
use it? Yeah. So it's got the checksum from the original on the primary, because it come across in the stream replica, and then it does it on the actual object that it's got a copy of, checks those. If they match, we're all good. We're off. If they don't match, would it go back and try and resync? What would be the actions at that point?
Yeah. Yep. So I guess we can just get into verification now. I think we're there.
Yeah. And there was another one related to just bringing it up in case we forget it. Was if the master hadn't done the checksums, I think there was an issue. If it hadn't done, but it's been copied, how is that even possible? But we can come back to that one, right? Let's talk about verification.
Yeah, that's related to this thing, which I'm fixing at the moment. So,
Oh, okay.
I think it's best to leave that one just out of this thing.
Okay, sounds good.
Yeah, I don't think it's worth.
Sure.
Okay. So verification. All right. Well, okay, yeah. So we've already covered the overview of verification, right? The primary creates a checksum, secondary creates a checksum, compares it, if it doesn't match, then the secondary says failed verification, failed sync, because apparently this thing is not the same. So interestingly, what that means is failed verification on the secondary side is not a valid state, because it should always immediately transition to failed sync. And if something's failed sync, verification doesn't come into play. It's not pending, it's not success, it's not,
Sure.
but
Makes sense.
we record the message for the verification failure, but like it's not really verification failed, it's really sync failed. That's an interesting side note. So to talk, oh, go ahead.
So, but that bit of information might be useful for someone troubleshooting it, right? So we would hold that information it has failed, because I guess if it's happening fairly regularly, then there's more of a systemic issue rather than, oh, it's just bad, it got corrupted on the way or something like that. If everything's failing verification, then there's probably something bigger going on.
Or like maybe it's more likely that it's a geo problem.
Yeah,
absolutely, everything's getting covered. Yeah, true.
So because if you're just transitioning the state as far as the user, they're just seeing syncing fail, but actually it's not just syncing. Things have come across, but look, the verification is failing. So I guess we're just as long as the information is there, they can decipher what's gone wrong. But if we're hiding that information, I think that could be more difficult for someone to troubleshoot ultimately. Okay, cool. And I'm just looking at these two, the couple of fields that you've got there. You got checksum mismatch, which is a Boolean, makes sense. Verification checksum, and then verification checksum mismatched. They're both byte arrays. What's the difference between the two?
Who's here? Yeah. Okay. So verification checksum is what did I checksum on this site,
Mhm.
and if a mismatch was detected, then this becomes true instead of false, and the primary side checksum gets recorded in here.
Ah, right. Okay.
Yeah.
Okay.
Yeah, that's not totally obvious.
I thought it might be something like that, yeah, but it wasn't quite sure. Okay, cool.
Yeah.
All right, well, so thanks for that bit. So if you never kind of sit in a verification failed state, you move immediately to a sync failed state and continue and try and re-fetch the data.
Yeah. Actually, now that I think about it again, maybe it wouldn't be a bad idea to let something sit in verification failed and until like 10 tries, because checksumming is so much
Cheaper, right? Yes.
cheaper than re-downloading the thing and then
But why would you want to retry checksum? I get with verification. Would it succeed after a repeated attempt?
That's true. That's true. It's very unlikely to succeed. And if it does succeed, you'd still want to be worried, maybe. Like,
Could you would be worried because is it doing the checksum on partial data at that point? Would be the only, I guess.
or
Why would you get
why
what?
you'd be like, why did it fail like 5 times and then
Yeah.
succeed and I didn't change anything? Yeah.
Yeah.
Well, I don't know.
What to think about?
Yeah. Yeah. Also, currently it just goes, if the verification fails, it goes straight to failed sync. Yeah. Actually, we have some other fields here. So to mention, forced to re-download for Git repos. There's like 2 approaches to syncing, and that now there's technically 3. But Git fetch versus fireballing the Git repo on the primary side and having the secondary downloaded at an endpoint.
Mm-hmm.
And that's called snap. We call it snapshotting, and that's what we use during re-download.
Okay.
And that one's come up, not infrequently with customers because it's possible for one approach or the other to be not working, but the other one is working. And so forced to re-download comes into play when you go to the UI on the secondary and you click re-download for a particular thing.
Okay.
So you're forcing them.
Is it re-download or resync at that point? Is there a download?
There's a resync,
Action.
yeah,
Resync.
which is
Okay.
like the regular way, yeah. and
Okay.
then you can force to re-download.
Are they the same? So as far as the UI is concerned, is it resync or is there a separate action for re-download there?
There's a separate action for re-download.
Okay.
Yeah. Let me just double check that.
I really need to get my instances running again. Hopefully when I get my laptop tomorrow, I will have
Oh, I thought we had a re-download button. Guess we have re-verify.
Okay.
I thought you could set it. Well, anyways, I guess force to re-download is used. Background.
Okay.
Second.
So yeah.
Yeah. So like, if a secondary tries to sync something and this no repository error gets raised, then we set force to re-download repository to true, and the next sync job will try to snapshot it. Yeah.
Gotcha. So a verification failure doesn't automatically set the force to re-download flag. That's different.
Yeah. Yeah. Right.
Okay.
Re-download. Re-download is also used when retry count is higher than 10. So that's how it started. It was kind of like you kept trying to do git fetch 10 times and it didn't work. Then maybe you should try the snapshot way, regardless of whether you got
Well, right, gotcha. It's a backup kind of method to try and sync. Okay.
Yeah, but the problem is like too many times we've ran into the case where for some reason, well, there was a bug for a long time. Re-download, but the snapshot way wasn't working, but git fetch was.
Okay,
So
right.
it's extremely painful for customers to be like, resyncing keeps trying to happen, but it just fails every time. But then when we go in and we get to Rails console and make it sync with a git fetch, it works. So I added this thing where if it's an odd number of retries, then just do the snapshotting. Otherwise, try git fetch. So that way, after 10 tries, it flips back and forth between the approaches.
Okay, gotcha. Okay.
But actually, did I put that on? Okay, good. Yeah, so that's because this projects are using the legacy stuff, but framework repository sync services used by SSF to sync snippets and group wikis.
Okay. Cool. Anything else on verification we need to?
If you want to go into some more details of verification, there's a bunch of like there's a bunch of things in the background. Really can't type in that. So one thing to mention. Oh, there's a big thing to mention.
Mhm.
Verification state. There's a verification state for resources on the primary side as well. Right, to manage, like you're going to track like
Mhm.
failed, like retry, did it succeed, all that stuff. And at first we were putting all of that on the source table. So like package files table, I added all of those verification related fields.
Right.
And that's fine in many cases, but we have some cases like job artifacts where there are like over 100 million job artifacts on GitLab.com. And so like extending the job artifacts table is like bad for performance, bad for well, mainly performance, but like it, there's more than one reason why that is the case. But anyways, it's a huge table, so we don't really want to add these fields, especially if they're only like on GitLab.com, we're not using Geo, so like they're not even relevant to GitLab.com.
I see.
Or self-managed customers might not be using Geo, so that they're not. So anyways, I think it was for job artifacts specifically, like we added the verification fields in a separate table.
Mhm.
That adds a whole bunch of complexity, but it was seemingly necessary. And one of the bits of complexity that came out of that was this worker. And so this worker iterates over the table, the source table, and
I can't
backfill.
see if you're pointing to another window.
Oh.
I can't see that.
What can you see right
I
now?
see your browser. So I can see the georeference architecture. That's
Oh
all.
my goodness, I keep doing stuff in my IDE thinking that you can see
I
it.
assumed you didn't want us to see what you were doing. You
Oh
just
my
that is it.
goodness.
But that's there we go. Now we can see it.
All right. Here's my IDE, which I was pointing to for a long time in the other discussions. Verification state backfill worker iterates over the source table to backfill the verification state table. Did Chris cut out my talking just now? Did you hear
You
me
broke
talking?
up there, Mike. Couldn't catch you.
Oh, I was wondering if you could hear my talking.
I can't hear you typing. Nope.
Oh, okay, great. And anyways, so the verification state table is separate for especially these big tables. And I think we decided that this is just the way going forward for everything,
Okay.
even small tables.
How about we do a follow-up
Yep.
session on this, Mike? I know we've been going for some
Going
time.
for a
Does
while. Yeah.
that
Okay.
make sense? We covered a lot of ground and it's been super helpful. But how about we pick this up on our next session? I'll
Yes.
make a note. Verification tables.
For sure.
I'm going to stop. Thanks very much, Mike, for this. Just got to stop the recording. That worked.